Okay, we're back again looking at some normals and tangents yet again. We're given a function f, which is this graph here, and we want to find the tangents to the curve that goes through this point, -1, 22. The biggest problem with, or difference with this kind is that this point is not on the curve. This point is going to be approximately somewhere here probably. Okay, so that's the point -1, 22. And so when I have that scenario, I'm looking for the tangents. So there might be a tangent that might be somewhere here. Let me see if I can, roughly there, that would touch the curve up here. And then probably another tangent might be, here's that point, another tangent probably roughly somewhere there. And so I'm looking for those two tangents. Well, to do it, I need, anytime I want to find an equation of a line, I need 2 points. And I need a slope. I have 1 point, but I don't have a slope, and I don't have another point. One thing I do know is that any point on this curve, for example, this one, is going to be represented by, I'll call it A. I don't know what the value is, but it could be A. And the y value for my function A, if I take A and I plug it in for x, the calculation for whatever A is would be 2a squared minus 12a plus 16. And that's always the y value. So if this A is 1, I plug in 1 here and I get 2 minus 12 plus 16. I do the calculation to get y. And so I have this point and I have that point. Now I've got to think about, I have 2 points. I also need a slope. Well, slope I know is the derivative. So if I take the derivative of that function, which gets me 4x minus 12. Okay, I want to find the slope of this dotted line here. Now if I want to find the slope of that dotted line here, I'll highlight it. I want to find this slope. It's the slope at point A. So I'm going to find f prime at A is simply 4a minus 12. This is an expression for the slope of the tangent. But my problem is I don't know what A is. And so what I want to try and do is think of another way to find my expression for the slope of the tangent. And I know from early on in mathematics that slope is always the change in y over the change in x. Well, I have a point here and a point there. So let's do our change in y over change in x. So our one point is 2a squared minus 12a plus 16. Subtract, my y value is 22, over, nice line, my x value is a minus a -1. This is also equivalent to the slope of the tangent. Both of them are in terms of a, so I can find a. If I set them equal to each other, since they're both the same thing, I can then solve for a. So I'm going to make the equation 2a squared minus 12a minus 6 over a plus 1, and that has to equal 4a minus 12. That's the key relationship to get. You have to come up with that equation yourself. Solving for a, I get 2a squared minus 12a minus 6 equals a plus 1 times 4a minus 12 by just cross multiplying. Doing some algebra on that. To solving for this, and I get 4a squared minus 12a plus 4a minus 12. And I'm going to bring all these over to this side of the equation. So 0 will be 2a squared. Well, that's minus 8. Oh, actually, these 12s will cancel away. If I go do this, I can cancel out those 12s. And so I'm left with plus 4 a, add the 6, I get minus 6. This factors nicely. I get 2, a squared plus 2a minus 3. And again, I can continue to factor 2, a minus 1 and a plus 3. So a equals 1, a equals minus 3. So what this means, going back to my sketch, is that this a value could be the 1, and the a value that would be up here, the point up here, would be the negative 3. Next part, I actually have to find the tangents. There's two different tangent lines. In order to find the tangent, I'm going to find two different lines. Let's use a equals 1 first. To find the slope of the tangent, I know it's the derivative. And the derivative was 4a minus 12, which ends up being negative 8. As always, I need to find the equation, so I use y minus y1 equals m x minus x1. And I can use the point negative 122, which I know is on the line. Plug it in. Y minus 22 equals negative 8. X plus 1. So y minus 22 equals negative 8. X minus 8. And finally I get y equals negative 8x, add 22, and I get 16, 14. Okay, so here's the one tangent. If I do the other tangent, the slope of the second tangent, I know is going to be 4 times negative 3 minus 12, which is negative 24. Again, I'm going to plug in the same point. So y minus 22 equals negative 24x plus 1. So y minus 22 equals negative 24x minus 24. Add the 22 over. I get negative 24x minus 2. And so here are my two tangents. And so going back to recap, I have a point not on the curve, so I find a general point for any point on the curve. I make two expressions for the tangent, and that's the key to this whole problem, is this step right here. One you know is the derivative, that's the slope of the tangent. One you know from earlier mathematics, change in y over change in x is another tangent, or is another equation for the slope.